Okay. Good day to our lecturer. And today, our team will be presenting our system analysis and design project for the course DITP 2213. Our project is titled Time Tracking and Penalty Deduction System for Employees. Before we begin, let me introduce our project team. I am Muhammad Amiam Shah bin Hamdan, the project leader. Joining me today are Ahmad Arik bin Azwa, our system analyst, and Muhammad Amar Haris bin Yazid Hamdi, our database designer, and Faris Zafar bin Che Hussein, our UIX designer. Let us start by looking at the core objectives of this proposed system. Slide 2. Okay. The main goal of our proposed system is to modernize standard HR operations through automation. We identified four key areas to address, which is firstly, centralized time tracking to accurately record employee time in and time out data in a single centralized database. And secondly, automated penalty calculation to automatically apply salary deductions based on predefined HR penalty rules, such as a grace period limit. And thirdly, paperless payroll to reduce manual paperwork and minimize potential human errors in payroll calculation. And fourth, user-friendly interfaces to provide intuitive input and output screens designed for both HR administrators and employees. To better understand the boundaries of what we are designing, I will now hand the floor to Ari to explain the system scope.
Okay, thank you, Ame. Let's slide 3. Okay. When proposing this system, it was important for us to clearly define what lies within our system boundaries. Our scope activities focus entirely on system analysis and design. These include enabling, enabling daily clock in and clock out tracking, calculating total working hours, processing automated penalty deduction from the monthly salary, and generating monthly attendance reports and digital payslip. On the other hand, our scope limitation include actual bank transfer and payroll payouts, as we do not handle financial integration. We also hiring and firing for processor of employees. And lastly, the physical coding and development implementation, as this project is limited to the analysis and design phase. Next, Ame will explain our project timeline and methodology.
Thank you, Ari. For this project, we adopted a linear documentation-driven methodology divided into three distinct phases. Uh, the first one is planning and requirements analysis, which took place in April, week 4. The outputs of this phase include the work breakdown structure, Gantt chart, PERT chart, and the project charter. And secondly, system analysis, spanning from April week 4 to May week 1. This phase focuses on producing the context diagram, as well as level 0 and level 1 data flow diagrams, which known as DFD. And third, system design, running from May week 1 to May week 2. This resulted in our database architecture through the enhanced entity relationship diagram, which is known as EERD, and our input-output user interface mockups. Slide 5. And this diagram illustrates our 3-week sprint timeline. We initiated the sprint in April week 4 with task A, where all members spent 2 days finalizing the project title and methodology. Following this, we worked on parallel tasks. I drafted the project charter and constraints in task B. Arik work on requirements and context diagram. In task C, Faris drafted the initial UI mockups. In task D, yes, in task D. Moving into the dependency phase in May week 1, Arik designed the DFD level 0 and 1. In task A, while Amar spent 5 days designing the EERD database in task F. Finally, in May week 2, I compiled the final report under task G, leading to our submission on May 15th. Slide 6. To ensure the project progressed smoothly, we distributed responsibilities based on individual roles. As the project leader, I managed our scheduling, oversaw the grading rubrics, and compiled the final report. And Ari, our system analyst, mapped out the system logic and data flows, specifically taking charge of the context diagram and DFDs. And Amar, database designer, designed the physical data structure and created the EERD. And lastly, Faris, our UI UX designer, focused on crafting user-friendly form inputs and output report mockups to meet user requirements. I will now quickly cover the operational constraints we faced during this project. Move on to slide 7. Every system design has constraints, and ours was shaped by 4 primary factors. And one of them is time constraints. We adhered to a strict deadline for our Progress 1 submission by May 15, 2026 during semester 2. And secondly, scope constraint. The project is strictly bounded to analysis and design models. No software coding or development was executed. And for 3, resource constraint. The workload was limited to the human capital of our 4 assigned team members. And the fourth one is technology constraint. We relied on standard, accessible diagramming tools such as Draw.io to generate our architecture. And now I will pass the presentation back to Arik to discuss our system context and logical processing.
Okay, thank you, Amir. Let's look at the contact diagram we established for the system. We have two main external entities interacting with the central time tracking and penalty deduction system. Okay, firstly, we have employees who provide clock in and clock out times as input to the system and in return receive digital payslip as outputs. Secondly, we have HR admins who input system rules and penalty rate parameters. In return, the system provides them with monthly attendance reports. This diagram outline how data flow in and out of our system boundaries. Next. Okay, so to break down what happened inside the system, we designed a 4-step logical processing pipeline. Step 1 is the time capture. The system receives and logs the raw clock in and clock out data submitted by the employee. Next step is the validation check. The system cross-references these log times against the employee's assigned shift schedule to identify any anomalies. Step 3 is the penalty calculation. If an anomaly is found, the system triggers built-in mathematical formulas to calculate deduction amounts for late arrival or early departure. Step 4, which is the last step, is data storage. The system then push this finalized data into the payroll and attendant data stores. I will now hand over to Amar to walk us through the database architecture.
Thank you, Ari. To support this logical pipeline, we design a relational database structure. At the center of our database architecture is a core triad of tables. First, the employee table, which holds the primary key, employee ID, and stores the employee's base salary. This table has a one-to-many relationship with the payroll records table, which stores the calculated net pay and total penalties for each pay cycle. The employee table also links in a one-to-many relationship to the attendance log table, which logs the daily clock in time, clock out time, and calculates the total hours worked. And continue to slide 11. To handle different job roles within an organization, we apply a specialization in our Enhanced Entity Relationship Diagram (EERD). The superclass employee branch out into three disjoint subclass. First, office admin. This subclass stores specific attributes like HR certification and accession number and can branch further into roles like HR officer and payroll clerk. Store operation. This subclass represents on the ground staff, branching into roles like stock clerk and shift cashier. Right? Manager. This subclass contains management specific attributes such as management level and location ID, which branch into store manager and assistant manager. This specialization allow us to assign different shift roles based on their operational roles. To ensure HR policies are properly enforced, we introduce two configuration tables that interact with our daily logs. The shift table dictates the official start time and end time for an employee schedule. The policy rules table stores administrative settings such as late grace period minutes and the penalty rate per minute. By intersecting the data from both the shift and policy rules tables, the attendance log table can dynamically calculate Boolean flags like each overtime shift and determine the exact penalty deduction amount. Next, Faris will present the user interface designs we create for this process.
Alright, thank you, Amma. We designed our user interface with a focus on simplicity and clarity. On the left, we have the input design, which is HR penalty rule form. This is designed for HR administrator to easily input dynamic variable. Then can set the grace period in minutes, define the penalty rate percentage, choose the effective dates, and select the specific role type without needing technical database knowledge. On the right is the output design, which is automated salary deduction report. This serves as a clear, high visual receipt for employees. It separates base pay, lists itemized penalty deduction by specific dates, and display the final calculate net pay to ensure transparency and reduce confusion. To illustrate how all our design component works together, let's trace the data lifecycle of single event. An employee arriving 15 minutes late. The trigger, the employee clocks in 15 minutes late. Step 1, the input UI. The interface captures this time, noting it is 15 minutes past the scheduled shift start. Step 2, the DFD process. The validation system process this input, recognize the 15-minute discrepancy, and um, and okay, my bad. Um, and route the data to the penalty calculation process. And step 3, the ERD storage. The database references the policy rules table, finding that the grace period is only 10 minutes. It flags a violation, calculate the deduction amount, and update the payroll records table. And step 4, the output UI. At the end of the month, the system generates an itemized update payslip reflecting this specific deduction. And now, I will pass this presentation back to Ameh to wrap things up.
Okay, thank you, Faris. In conclusion, our team has mapped out the essential analysis and design blueprints required for this system, successfully achieving the requirements of course learning outcome 3. Our finalized deliverables include a defined project charter and constraints, completed WBS and Gantt spreads, map contents and data flow logical diagrams, a structured EERD architecture, and design input and output interface system. This concludes our presentation. Thank you very much for your time, and we are open any question or feedback you may have. Thank you.